All right, get ready because today we're diving deep into quantum computing.
Ooh, exciting.
It's a field that's definitely causing a stir.
For good reason.
Yeah, and for good reason.
Yeah.
Imagine, like, a world where we can design life-saving drugs, but, like, with pinpoint accuracy,
Wow.
create totally new materials, stuff we've never even, thought of before.
Right.
Or even crack the codes that, like, protect our online world.
It's incredible.
That's the promise of quantum computing, but
The question is
it all hype?
yeah, is it just hype?
Or are we, like, actually on the edge of, like, a huge technological revolution?
Well, there's definitely a lot of hype,
Sure.
but it is grounded in some really mind-bending science.
Okay.
And what makes quantum computing so different is how it processes information
Okay.
instead of bits, which can be either a 0 or a 1.
Right, like our regular computers.
Exactly. It uses these things called qubits.
Qubits.
Okay. Here's where it gets interesting.
All right, lay it on me.
A qubit can be a 0 or a 1,
Okay.
or both at the same time.
Both at the same time. Wait, what?
Yeah, it's kind of like a coin spinning in the air.
Okay.
It's not heads or tails
Right.
until it lands.
I see.
That's the power of superposition.
Superposition.
One of the fundamental principles of quantum mechanics.
Okay, so these qubits can be in multiple states at once.
Exactly.
How does that translate into, like, actual problem-solving power?
So think about it this way.
Okay.
A regular computer works through problems step by step,
Okay.
like reading a book one page at a time.
Gotcha.
A quantum computer, with its qubits in superposition, can explore like many possibilities all at the same time.
Oh, wow.
So it's like reading every page of the book at the same time.
That's crazy.
Yeah.
Okay, so it's not just, like, about speed then.
No.
It's about tackling these problems in, like, a totally different way.
Exactly, a fundamentally different way.
Okay, now another term that keeps popping up is entanglement.
Ah, yes, entanglement.
What is that all about?
This is where things get really spooky.
All right,
Even for physicists. Okay, imagine you have two of those spinning coins we were talking about.
Okay.
They're linked in a way that even if you separate them by a huge distance,
Uh-huh.
knowing the state of one
Yeah.
instantly tells you the state of the other.
Whoa. Like they're communicating somehow?
It's like they're communicating faster than the speed of light.
No way.
Yeah, it's pretty wild.
That's mind-boggling.
It is. That's entanglement.
Entanglement.
And it allows qubits to work together in a way that those classical bits just can't.
Okay, I'm starting to see why people are so excited about this.
Yeah.
We've got these qubits. They can be in multiple states at once.
Right?
And they're connected through this, like, bizarre entanglement thing.
It's pretty amazing.
How do we actually harness that power to do something useful?
That's where quantum algorithms come in.
Quantum algorithms, okay.
Just like regular computers need software,
Right.
quantum computers need algorithms that are designed specifically to leverage superposition and entanglement.
To take advantage of those, yeah.
Yeah, exactly. There are a few famous ones out there,
Like what?
like Shor's algorithm,
Shor's algorithm. Okay.
which has the potential to, like, break the encryption that protects so much of our online world.
Shor's algorithm, that does sound familiar.
Yeah.
I think I read something about that.
It's the one that can factor large numbers
Okay.
exponentially faster than any classical algorithm we know of.
So, like, way faster.
But way faster. And this has huge implications for cryptography
All right.
because a lot of our online security systems rely on the fact that it's really difficult for classical computers to factor those large numbers.
So, theoretically, a quantum computer running Shor's algorithm,
Could crack the codes that protect everything.
like our online banking,
Yeah.
communications, everything.
It's a concern, definitely.
Wow, that's a little scary.
It is a serious concern,
Yeah.
but it's not all doom and gloom.
Okay, good.
Researchers are already working on something called post-quantum cryptography,
Post-quantum cryptography.
which is all about creating new encryption methods
Okay.
that can resist attacks from both classical and quantum computers.
So it's like an arms race.
It is a bit of an arms race.
But it's essential, right?
Yeah, it's essential to ensure our digital security in a future with these powerful quantum computers.
So it's like a high-stakes technological thriller playing out in real time.
Exactly.
But beyond just breaking codes,
Yeah.
what else can these quantum algorithms do?
Well, there's Grover's algorithm,
Grover's algorithm.
which is really good at searching unsorted data.
Okay.
Imagine you have a massive database.
Got it.
You need to find one specific piece of information.
Yeah.
Grover's algorithm could speed up that search significantly.
Really?
Yeah, which has applications in all sorts of fields,
Like what?
like drug discovery, material science, even financial modeling.
So we have quantum computers that could potentially factor large numbers,
Yeah.
search data faster.
Right.
And what else?
The sources mention something about simulating molecules.
Oh, yeah, simulating molecules. What's that all about?
That's one of the most exciting areas of quantum computing,
Okay.
because simulating molecules at the atomic level is super complex
Right.
for classical computers.
I can imagine.
But quantum computers,
Right.
with their ability to handle tons of data and explore multiple possibilities at once,
Right.
they could revolutionize fields like drug discovery and material science.
So instead of spending years and billions of dollars developing new drugs or materials just through trial and error,
Right.
we could use quantum computers to simulate and design them with incredible precision.
That's the idea.
Wow.
Imagine designing a drug that targets a specific disease at the molecular level
Yeah.
with minimal side effects,
Wow.
or creating materials with properties we can only dream of today.
That's pretty amazing.
The possibilities are truly mind-boggling.
It does sound like we're on the verge of something huge.
It really does.
With all this talk of quantum supremacy and, like, future potential. Are these quantum computers actually outperforming classical computers yet?
That's the million-dollar question.
Are we already seeing, like, real-world applications?
The answer is it's a bit nuanced.
Okay.
There have been claims of achieving quantum supremacy,
Okay.
which basically means a quantum computer solving a problem that's pretty much impossible for even the most powerful classical computer to solve.
Oh, wow.
But there's still debate about whether those claims really hold up
Uh-huh.
and whether the problems that were solved actually show practical value.
Okay.
The truth is, we're still in the early stages of quantum computing.
Yeah, it's still early days, right?
Exactly.
And there's some big hurdles to overcome.
Definitely. What's holding quantum computing back from reaching its full potential? One of the biggest challenges is how fragile those qubits are.
Oh, right, the qubits.
They're incredibly sensitive to noise and any environmental interference.
Okay.
It's like trying to balance a pencil on its tip.
Okay.
The slightest little disturbance can knock it over.
Right.
Qubits are even more delicate than that.
Wow.
Maintaining those delicate quantum states
Yeah.
requires incredibly controlled environments,
Like what?
often involving ultra-low temperatures and shielding them from even the tiniest vibrations.
So building a quantum computer isn't just about, like, cramming in more qubits.
No, it's much more than that.
It's about creating and maintaining this environment where those qubits can actually do their quantum magic.
You got it. The quality of the qubits matters just as much as the quantity.
Right, the quality over quantity.
Exactly.
And maintaining that quality.
It's a huge engineering challenge.
Yeah, I bet.
It often requires extremely low temperatures, near absolute zero,
Wow.
and highly controlled environments
I see.
to isolate those qubits from any outside interference.
So these quantum computers, they're not exactly something you can just plug in at home.
Not quite yet.
Okay, good to know.
But that doesn't mean they're totally inaccessible.
Okay.
There are already companies that offer cloud-based access to their quantum computers,
Oh, interesting.
which means researchers and developers don't necessarily need to own one of these expensive and complex machines
Right?
to actually start experimenting with them.
That makes a lot of sense.
Yeah,
That's fascinating.
it is.
So it's kind of like the early days of the internet,
Yeah, I was just thinking that.
where access was limited, but, like, the potential was so clear.
Exactly.
So while we might not have, like, quantum computers in our homes anytime soon,
Right.
the power of this technology is becoming more widely available.
That's the exciting part.
That is really exciting.
It is.
So with increased access, I imagine that comes with increased innovation.
It does. The sources point to a real surge in research and development efforts,
Yeah.
fueled by both public and private investments.
So it sounds like a lot of people are betting big on the future of quantum computing.
They are, and for good reason.
It seems like there's a lot of potential.
There is. The potential applications are mind-boggling.
Okay, well, let's dive into some of those potential applications a bit deeper.
Sounds good.
What's got you most excited?
From a scientific perspective,
Yeah.
the possibilities for quantum simulation are just incredible.
Okay.
Imagine being able to simulate how molecules behave at the atomic level,
Wow.
or even the dynamics of black holes.
That would be groundbreaking.
It would be incredible.
What kind of impact could that have on, like, our everyday lives?
Well, let's take medicine, for example.
Okay.
It could completely revolutionize drug discovery instead of relying on trial and error, which can take years.
Right. And tons of money.
Exactly. We could use quantum simulations to design drugs that precisely target specific diseases.
Rah.
at the molecular level.
So we're talking about personalized medicine,
Yeah,
potentially even cures for diseases that are currently incurable.
exactly. It's really exciting.
It is exciting, and it's not just medicine, right?
Right.
In material science, quantum simulations could lead to the development of entirely new materials
Cool.
with properties that we haven't even thought of.
Right. We can't even imagine them yet.
Super strong materials,
Yeah.
super light,
Uh-huh.
superconductive materials.
It's mind-blowing.
The possibilities seem endless.
You really do.
And those new materials could have applications in everything.
Oh, absolutely.
From like renewable energy
Yeah.
to aerospace
Mhm.
to electronics.
That's a whole new world.
So it's like we're on the verge of a materials revolution.
It really feels that way.
What about artificial intelligence?
Oh, that's a big one.
How could quantum computing impact that field?
Well, there's this thing called quantum machine learning,
Okay.
which is still pretty early,
Right.
but it holds immense promise.
Okay. I'm intrigued.
Quantum algorithms could potentially speed up the training of AI models.
So AI that can learn faster,
Yes.
solve more complex problems,
Exactly.
maybe even surpass human intelligence.
It's a possibility.
Okay, so AI that can think faster than us.
It's definitely a possibility, although it's still a topic of much debate
Right.
and speculation.
But the potential is there.
It is.
It's exciting.
Yes,
But also, I'm a little bit unnerved by that.
I understand that.
But with all this talk about the amazing potential of quantum computing,
Yeah.
we can't ignore the potential downsides, right?
Right. We have to be realistic.
We talked earlier about the threat to encryption.
That's a big one.
What else should we be, concerned about?
Well, as with any really powerful technology,
Yeah,
there are ethical considerations.
of course.
One of the big ones is access and equity.
Right, who gets to use this?
Exactly. Who will have access to this technology?
And will it be evenly distributed?
That's the question.
Or would it just make existing inequalities worse?
That's a very real concern.
That's a crucial question.
It is.
I mean, we've seen how technology can create divides in society, right?
Absolutely.
And we need to be mindful of that as quantum computing keeps advancing.
Absolutely. We have to be very careful.
And beyond access, are there concerns about the potential for, misuse?
Oh, definitely.
Like what?
Could quantum computers be used to develop autonomous weapons systems?
Right, machines making life or death decisions.
Exactly, without human intervention.
That's a scary thought.
It is.
Could they be used for mass surveillance
That's another concern.
on a scale that we can't even imagine today?
It's hard to even comprehend.
These are some really big questions.
They are.
And it seems like there's a lot to consider as we move into this, uncharted territory.
There is. It's a new world.
It is.
But having these difficult conversations now
Yeah,
is essential.
I agree.
We need to be proactive in shaping a future where quantum computing is used responsibly and ethically.
So it's not just about the technology itself.
Right.
It's about how we use it.
Exactly.
It's a responsibility that falls on all of us, right?
It has.
From the scientists and engineers who are actually developing the technology
Yeah.
to the policymakers and, just everyday citizens who will ultimately be impacted by it.
We all have a role to play. We need to work together to make sure this powerful technology is used for good,
For good.
to advance human knowledge and well-being.
Right. Not to create new threats
Exactly.
or make existing problems worse.
We have to be very mindful of that.
It's a tall order,
It is.
but I think we can do it.
I agree.
We've faced technological revolutions before,
We have.
and, we've learned from those experiences.
Hopefully.
I think we could apply those lessons to the quantum revolution
I think so too.
and work towards a future where this incredible technology benefits all of humanity.
That's the goal.
This deep dive into quantum computing has been a wild ride so far.
It has been fascinating.
We've learned about qubits,
Yeah.
superposition,
Entanglement.
quantum algorithms,
It's a lot to take in.
and the potential for both, like incredible breakthroughs,
Right.
but also unforeseen challenges.
We have to be prepared for both.
It seems like we're just scratching the surface of
Yeah.
this incredibly complex and rapidly evolving field.
It's moving so fast.
It really is. But we've covered a lot of ground in part one of our deep dive,
We have?
and there's so much more to explore.
Oh, absolutely.
Are you ready to continue this journey with me?
I am. Let's keep going. It really does feel like we're on the edge of a new era, doesn't it?
It absolutely does, but with all this talk about the, amazing potential of quantum computing, I can't help but wonder what the reality is like right now. Are there actual quantum computers out there, doing real work? Or is this all still mostly theoretical?
Well, it's a little bit of both, as I mentioned earlier. We're still really in the early stages of quantum computing. Building these machines is incredibly complex. But there are real quantum computers out there doing real work, even if it's not quite the, mind-blowing stuff we've been talking about just yet.
Okay, so what kind of quantum computers exist right now, and what are they being used for? The sources mentioned a company called D-Wave. What's their story?
D-Wave is a really interesting company. They've been building and selling quantum computers since 2011, which is pretty remarkable. Their machines use a technique called quantum annealing.
Quantum annealing.
Yeah.
That sounds familiar. Can you remind me what that's all about?
Sure, it's kind of like finding the lowest point in a really complex landscape. Imagine like a mountain range with tons of peaks and valleys. A classical computer would have to search through each valley one by one to find the lowest point. Quantum annealing lets a quantum computer explore all the valleys at the same time and quickly settle into the lowest one.
Which represents the optimal solution. So
Exact.
it's about finding the best solution out of a bunch of possibilities.
Right.
It sounds like it could have applications in a lot of different fields.
You got it. Companies have been using D-Wave's quantum computers for things like optimizing traffic flow in cities, improving financial modeling, and even speeding up machine learning algorithms. There's a famous example where Volkswagen used a D-Wave computer to optimize bus routes in Lisbon, Portugal, which significantly reduced travel times during a big tech conference.
So that's a real-world impact.
It is. It's a real-world example of quantum computing already making a difference.
That's pretty cool, even if it's not, quite at the level of simulating molecules or breaking encryption yet.
Right. It's definitely a step in the right direction. And D-Wave isn't the only player in the game. Companies like IBM, Google, and Microsoft are also developing quantum computers and making them available through cloud-based platforms.
You don't have to actually own one
Exact.
to use it.
This is a huge development because it means researchers, developers, and even companies can experiment with quantum computing without having to build their own expensive machines.
So it's like democratizing quantum computing, right?
Exactly, making this powerful technology accessible to a much wider audience.
That's really exciting.
It is, and with increased access comes increased innovation. We're seeing a huge surge in research and development efforts fueled by both public and private investment.
A lot of people are putting money into this.
Governments around the world are recognizing the strategic importance of quantum computing, and companies are racing to develop new applications and technologies.
It feels like we're on the cusp of a quantum gold rush, with everyone wanting a piece of the action.
There's definitely a sense of that. But amidst all the excitement and investment, it's important to remember that building practical quantum computers is still incredibly challenging. We've talked about the fragility of qubits and the need for highly controlled environments. These are engineering challenges that require time, innovation, and significant resources to overcome.
Yeah, it's easy to get caught up in the hype and forget about the very real hurdles that still need to be cleared. So what are some of the key areas of focus right now in terms of advancing quantum computing technology?
One of the most critical areas is improving the quality and stability of qubits. Researchers are exploring different ways to build qubits that are less prone to errors and can maintain their quantum states for longer periods. This is essential for building larger and more powerful quantum computers that can tackle more complex problems.
It's like trying to build a more intricate and stable house of cards. The more cards you add, the more challenging it becomes to keep it from collapsing.
That's a great analogy. And beyond improving the qubits themselves, researchers are also working on developing better error correction techniques. This is about building redundancy into quantum computers, so that even if some qubits fail, the computation can continue without losing its integrity.
So it's about making quantum computers more robust and fault-tolerant, which is essential for moving beyond the experimental stage and into practical applications.
Exactly. And then there's the development of new quantum algorithms. We've talked about Shor's algorithm for factoring numbers and Grover's algorithm for searching. But there is a whole universe of potential quantum algorithms out there waiting to be discovered.
So it's not just about building better hardware.
No.
It's also about developing the software and algorithms that can really harness the power of quantum computing.
Precisely. And this is where collaboration and creativity are key. We need computer scientists, mathematicians, physicists, and engineers all working together to push the boundaries of what's possible.
Okay, so we've talked about the current state of quantum computing, the challenges being faced, and the areas of focus for advancing the technology. But I want to circle back to something we touched on earlier, the potential applications of quantum computing. We've discussed drug discovery, material science, and artificial intelligence. Are there any other areas where quantum computing could have a significant impact?
Well, one area that's particularly fascinating is cryptography. We've talked about the threat quantum computers pose to existing encryption methods.
Right, how they could break them.
Exactly. But they could also lead to the development of entirely new and unbreakable forms of encryption.
So quantum computers could be both the problem and the solution when it comes to cryptography.
Exactly. Quantum key distribution, for example, is a technique that uses quantum mechanics to create a secure communication channel that's theoretically impossible to eavesdrop on.
That sounds pretty amazing.
It's like having a conversation where only you and the person you're talking to can hear what's being said, and any attempt to listen in would be immediately detected.
That's like something straight out of a spy movie. But beyond cryptography, what other applications are on the horizon?
Another area with immense potential is financial modeling. Quantum computers could be used to develop much more sophisticated models for predicting market trends, assessing risk, and optimizing investment strategies.
Wow.
This could have a major impact on the financial industry, leading to more efficient markets and potentially even reducing the risk of financial crises.
It's like having a crystal ball for the financial markets powered by quantum mechanics.
It's not quite that magical,
Right.
but the potential is definitely there. And then there are applications in areas like logistics and supply chain management. Quantum computers could be used to optimize delivery routes, manage inventory levels, and improve the efficiency of global supply chains, leading to cost savings and reduced environmental impact.
So from designing new drugs to creating unbreakable codes to optimizing global trade, it seems like there's no shortage of potential applications for quantum computing.
That's right, and we're really just scratching the surface as the technology continues to advance. We can expect to see even more applications emerge in fields we haven't even thought of yet.
It's a reminder that we're really just at the beginning of this quantum computing journey, and the most exciting discoveries are probably still ahead of us. But we've covered a lot of ground in part 2 of our deep dive. Shall we move on to the final part of our exploration?
Absolutely. Let's wrap things up and consider what the future holds for this incredible technology.
Yeah, it's kind of mind-blowing to think about how much could change with quantum computing. It's exciting, but it also, makes you think about how important it is to be careful and responsible with how it develops.
Yeah, I agree. It really does underscore the need for us to think ahead. We've explored the vast potential of quantum computing, but like you said, we also need to acknowledge the possible downsides. One of the most immediate ones we talked about is that potential threat to encryption, the foundation of our digital security.
Yeah, that's a little unnerving, the idea that quantum computers could crack the codes, protecting everything we do online. That's a pretty sobering thought. But we also touched on potential solutions like quantum-safe cryptography. Can you tell me more about that? Like, how does it work, and how far along are we in actually using it?
Quantum-safe cryptography, or post-quantum cryptography as it's also called, is basically a race against time. It's about developing new encryption methods that can withstand attacks from both classical and quantum computers. The good news is that governments and organizations around the world are taking this threat seriously. There are ongoing efforts to standardize quantum-safe algorithms and encourage people to switch over to these quantum-resistant systems.
So it's not just a theory. People are really working on getting ready for this quantum-safe future.
Oh, absolutely. There's a lot of research and development happening in this area, and it's encouraging to see it being prioritized. Think of it like future-proofing our digital world.
Right, getting ahead of the game.
Yeah.
So what would this transition to a quantum-safe world look like for, like, the average person? Would we have to change how we use the internet or our devices?
For most people, the transition should be pretty smooth. It's more about updating the underlying infrastructure and systems that things run on to make sure they're quantum resistant. You can think of it like upgrading the foundation of a house to be able to withstand earthquakes. You might not actually see the changes, but they're really important for stability and safety.
So it's more behind-the-scenes stuff rather than us having to learn a whole new way to do things online.
Exactly. It's about making sure our digital lives aren't interrupted and stay secure even when we have these powerful quantum computers out in the world.
Well, that makes me feel better.
Yeah.
But even if we can secure our digital lives in a quantum future, there are still a lot of things we don't know. What other impacts from quantum computing might we not even be able to imagine yet?
That's one of the most fascinating things about this field. It's like we're explorers looking out at this huge, uncharted territory. We can see the outlines of new industries and applications, but we can't make out the details. Yet the possibilities really are limitless.
That's kind of what it was like to think about the internet before it was everywhere, right? We knew it was going to be big, but no one could have predicted exactly how much it would change our lives.
Exactly. And that's what makes this so exciting and a little bit intimidating. We're standing right on the edge of something that could completely change everything, and it's up to us to figure out how to handle it responsibly.
So what can we actually do about that? How can we as individuals get ready for this quantum future and make sure it's a good one?
The first thing is just being aware of it. Understanding the potential benefits and risks of quantum computing is key. Talking about how it's being developed and used, asking questions, and staying informed are all really important.
It's all about learning, right?
Yeah,
Especially with something as powerful as this technology.
absolutely. And besides staying informed, we can support the development of responsible quantum computing by backing research, helping to create ethical guidelines, and advocating for fair and equal access to the technology. It's about making sure everyone benefits from this leap forward.
That's a great point. Technology isn't just about the science behind it. It's about people and how we can use our knowledge to create a better future for everyone.
I couldn't agree more. I truly believe that with careful thought and a commitment to ethical development, quantum computing can be one of the most transformative technologies we've ever seen.
Well, this brings us to the end of our deep dive into quantum computing. It's been quite a journey full of mind-bending ideas, incredible possibilities, and some things that make you stop and think. But ultimately, I'm feeling pretty hopeful about the future.
It's been fantastic exploring this with you, and I hope our listeners are leaving with a sense of wonder and a real appreciation for what humans can achieve.
Absolutely. And for those of you listening, we want to leave you with a challenge. As we've learned, quantum computing has a ton of potential, but it also needs our thoughtful guidance.
Yeah.
So we're asking you, what role will you play in shaping this quantum future?
Will you be on the sidelines watching it happen? Or will you jump in and be a part of this incredible journey? It's your choice, and the future is out there waiting.
Thank you for joining us on this deep dive into quantum computing. We can't wait to explore more fascinating topics with you in the future.